look at using the impulse and momentum to solve car problems. Now, whenever we're dealing with cars, we're going to have to remember all of the other equations that we've learned. That, like the net force equals ma, impulse equals change in momentum. Let's see, impulse equals ft, momentum equals mv. And we might even need to use some of the kinematic equations of motion. Let's start with problem 14. I have a car of mass, 100 kilograms, is at rest at a stoplight. So, I have a mass for a given. I know m is 1,000 kilograms. And it's at rest, so I know my initial velocity is 0 meters per second. When the light turns green, it's pushed by a force of 2,000 newtons for a time of 10 seconds. What's the value of acceleration for the car? So this is one of the times we really need to know what our unknown is, and our unknown is acceleration. Now let's see. F equals ma is the first thing that always pops in my head. So let's try the equation F equals ma. I have the net force and I have the mass, so I'm in good shape. So the acceleration is going to be the force divided by the mass. So the force is 2,000 newtons divided by the mass, which is 1,000 newtons, or 2 meters per second squared. Now, remember, my acceleration is 2 meters per second squared. I learned that in the last problem. It's the same car, mass of 1,000, and, now it's being pushed by 2,000 newtons for 10 seconds. All right, what is a change in velocity? Okay, whenever you see change in velocity, think impulse equals change in momentum, or maybe change in momentum is m delta v. Let's see. So I have my givens on the other page. I'm going to rewrite them. F is 2,000 newtons. T is 10 seconds. I see my impulse right there. And the mass is 1,000 kilograms. So this tells me, I want to say that the impulse is equal to Ft, and that is equal to m delta v. I'm looking for the change in velocity, so I'm going to divide both sides through by m. So the change in velocity, which is what I'm looking for, is going to be the force times time divided by mass. Let's see, the force is 2,000, time is 10 seconds, and the mass is 1,000. So 2,000 times 10 is 2,000. I'm just going to add a 0 here, divided by 1,000. Now look at this, zeros, zeros, zeros. No calculator needed. So this is 20 meters per second. The box answer. Same problem, and I want to know what is the value of the impulse. Now we kind of sort of almost did that. I know the impulse is Ft. So the force is 2,000 newtons times the time of 10 seconds. So this is 20,000 Newton seconds. Now, a short way to do this, if you don't have a calculator, you have 1, 2, 3 zeros, 1, 2, 3 zeros, and then there's another one. Same problem, but now we want the change in momentum. Let's see. I know the impulse is equal to the change in momentum. Oh goodness, I just found the impulse was 20,000 Newton seconds, and this must equal the change in momentum. So my change in momentum is 20,000. Now, I want change in momentum, and momentum is always measured in kilograms, meters per second. On these, I'll be looking to make sure you change your units over. Because if you tell me Newton seconds, that's impulse. If you tell me kilograms meters per second, that's momentum. Now, what's the final velocity of the car at the end of 10 seconds? Well, we have found that the acceleration is 2 meters per second squared. I'm going to write out all my givens. Mass is 1,000 kilograms. Force is 200 newtons. And time is 10 seconds. And I know my initial velocity is 0. Oh, goodness gracious. We're going back to kinematics. We want to know the final velocity. I know V final is V initial plus acceleration times time. This is 0. My acceleration is 2 meters per second squared times my time, which is 10 seconds. So 2 times 10 is 20 meters per second. Now, for the next couple of problems, the car continues at this speed for a while. So the car is going on at a constant velocity of 20 meters per second. Now, what is the value of the change in momentum the car experiences? The change in momentum is m delta v, or the mass times v final minus v initial, however you want to put it. But if it's going at the same speed, then then v final minus v initial is 0, or delta v is 0. So the momentum change is 0 kilograms meters per second. Now, what's the value of the impulse as it continues at this velocity? Impulse equals change in momentum. Well, I just found the change in momentum is 0, so the impulse is 0 Newton seconds. Again, make sure you're careful with your units there. Now we apply the brakes. The car comes to a stop in 4 seconds. What's the change in momentum? Let's see. The initial velocity of the car now is 2 meters per second. The final velocity is 0. And if you recall correctly, the mass of the car is 1,000 kilograms. So the change in momentum is m times v final minus v initial. So it's 1,000 times 0 minus 2, or negative 20 let's see, is that right? 1, 2, 3. Well, negative 2,000 kilograms meters per second. Did I do that right? No, because the velocity of the car isn't 2. Excuse me. Accidents happen. The velocity of the car is 20 meters per second. Double the problems. So this is minus 20. So this is minus 20,000 kilograms meters per second. Now they want the value of the change, so we're really looking for the positive here. What's the value of the impulse? Impulse equals change in momentum, so it's the exact same. And there'll be a negative sign there. What is the average force on the car to cause it to stop, and what's the acceleration? Well, let's see. We know that the time it takes for it to stop is 4 seconds. And we know that the impulse is 20. I'm just going to take the positive here because we're looking for values. So impulse equals F times time. So to find the force, I'm going to divide both sides through by time. So the force is the impulse divided by time. So this is 20,000 divided by the time, which is 4 seconds, or 5,000 newtons. Now, I want to find the acceleration. F equals ma. In these problems, when I ask for acceleration, think F equals ma. So the acceleration is the applied force divided by the mass. The applied force is 5,000 newtons. And the mass of my car is 1,000 kilograms. So I have an acceleration of 5 meters per second squared.